Alright, picture this. You're in your college kitchen, trying to make the world's best tomato sauce. But here's the catch. You need to add just the right amount of preservative so your sauce lasts longer, but not so much that it ruins the flavor. Sounds simple, right? Well, actually, it's a real-life math puzzle. Let's solve it with the power of derivatives. So, let's say I have a function, px, that tells me how effective the preservative is, depending on how much I add. Too little, and bacteria throw a party in my sauce. Too much, and it tastes like a science experiment. What I want is the amount, where the sauce stays fresh and still tastes like, well, sauce. Here's where differentiation steps in. Imagine plotting px on a graph. The x-axis is the amount of preservative, and the y-axis is the sauce greatness score. My goal? Find the peak of this curve. The math move. Take the derivative of px with respect to x, written as px. This tells me how fast my sauce greatness changes as I add more preservative. When px equals 0, that's my sweet spot, the top of the curve. That's where adding a tiny bit more or less preservative doesn't make it better or worse. In other words, I've found the preservative level. Let's make it concrete. Suppose px equals sine 2x2 plus 8x plus 10, where x is grams of preservative per liter. To optimize, I take the derivative px equals sine 4x plus 8. Set that equal to 0. 4x plus 8 equals sine 0. Solve for x and boom, x equals sine 2. That's 2 grams per liter for the perfect sauce balance. But hey, what about integration? Suppose I want to know the preservative used if I make 10 liters. Integration lets me sum up the effect. Just multiply my optimal amount by the total volume. So, 2 grams per liter times 10 liters. That's 20 grams total. See? Differentiation and integration aren't just abstract concepts. They're the secret sauce, literally, behind optimizing real-world problems, even in your kitchen. Next time you're adding something to your recipe or even making decisions in life, remember, sometimes finding the maximum, your optimal point, means taking a closer look at how things change. That's what math is all about. Stay curious and keep solving those tasty puzzles.